see if we can get this to work. Oh, like butter, it fits on there. Alright, that appears to be engaging to me. Alright, we're rolling free. That's a little tight. We want it to be rolling smooth, right? Yeah. But I gotta have some tension on it. Alright. Now what I'm gonna do, I'm at 968, I believe. And I'm at 971. No. 966. Oh, cooled down. Yeah, when I checked it before and when I had been cutting on it, it definitely heated up and the material expanded, because it's 950 plus 16, 966. And when I checked it before, I was at 968. I've got to hit 935. 935, that leaves me 30 thousandths. That's not a lot. I'm not going to try to do any correction to turn this back in, because I can see it's not running true on this side where I center drilled that. But I'm not going to cut up that far anyhow, and I'm expecting to overcome that in the course of turning the taper. So, can I get there from here? Oh. Not quite. So, I gotta readjust some things. You know, this is a right-hand turning tool, and I'm trying to turn left with it, but I think it was doing fine in both directions. If I was smart, I would grind another bit, or grind the opposite side of this. That would be a good idea, actually, but I'll take a cut. If it doesn't turn out okay, then I'll switch. Alright, so let's do a little bit of math. Alright, so I've done a little bit of math, and it looks like if the taper per foot is 0.60235, which is what South Bend says their taper is, and from what I measured on the back side of my spindle and the front side of the nose here, it is what the drawing says is 0.9. 0.938 for the large end and 0.788 for the small end. I've machined a shoulder here at 0.790 just to stop at, and I was going to make another mark here, but the shoulder that I machined before was already at 3.5 inches. The taper, the inside of the sleeve said it was 2.998 inches. I'm going to take 3.5 to give me a little bit of room for some stick out. I can always cut it off later. Alright, so if you take that, and that's over this distance, and I may be a little bit off, but I'll adjust it. I'm going to have to take this apart, fit it in the taper, in the spindle, I've got some Prussian blue, and check it to see how the fit is, and then I'll adjust accordingly. can take the dog off. I'm not threading, but I did put a divot in the shaft here for the dog, so it's going to go back in the same place. We will be registered, at least that far. And you know, I probably should have, well, we weren't that far yet, but I need to clean out the spindle because it's full of all the shop grease and oil and everything that was in here before. I tried to, there's a bit of a razor's edge there. I couldn't get at it. I was trying to nibble away in there to make this shoulder, and alright. Yeah, there's some tearing on the first corner of that thread. I had a problem getting this one off the first time. There's nothing in there but oil. There's nothing on here but oil. Grease and grime. Get it. Somebody's hit something against this, so I'll have to clean that up a little bit. Yeah, I'm hitting my major diameter already, and yeah, of course it wouldn't be able to contact. It's not, I was measuring the distance from the center to the set over point, and that's wrong. It's the distance of the work. So if I've got the distance of the work and the distance of the taper, because this is parallel to the ways. I'm not setting over from this point. At any rate, what oh, how many battery here? Alright, well, at any rate, what I found out is that it's 200. I'm real close. I'm touching, rubbing when I set it in the spindle. So I'm just going to set it back over 1,000th, and then I'm going to check it again. And then I'm going to do the same thing until I'm touching all the way on here, because right now I'm rubbing right up at the top. Alright, so we're set back up here, and I've started to cut out of aluminum a sacrificial taper to use as a lap for the inside of the spindle bore. And I've done a little bit of math here. The calculation to find the offset, tailstock offset, is major diameter minus minor diameter times the overall length of the part from center to center over the taper length times 2. And so I figured all this out. For me, it's my taper length is 2.9883, and do a little bit of math, and we come out to tailstock offset is 164 thousandths. And I'm going to cut this in the opposite direction that I cut the other piece on. The other one I cut the taper, it was made of stainless steel, so it was a little bit stiffer. And so I cut towards the headstock because I was having a little bit of problem with chatter. But now that I'm using aluminum, I'm going to cut the taper towards the tailstock. So I'll be moving the tailstock towards me rather than away. No. Yes. The tailstock moves towards me. To cut the taper towards the tailstock, and that way I can pull this out, and without removing the dog I can put it back in if I need to alter the taper setup. So we're going to shoot for 164 thousandths right now. I've got my dial gauge set up on the tailstock. I've zeroed it out, and I'm going to loosen one side, and then I'll tighten the other, and we'll just keep moving that way. And I'll move in increments so I don't build up too much slop. Alright, well, I just realized something after I moved all of this around, is that I actually moved the tailstock away from me instead of toward me, so I'll be... let me go back and change this, because I don't want to have to remove the dog. That was part of the consideration for taking that measure, so... Alright, we're set up here, we're oiled, we're good and cleaned up. Spray down the lead screw, just to give it some good travel, and we'll start taking our first cuts here. As soon as I find some, there we go, safety glasses. When I get done with this, I'm going to turn and use this tip, pointed tip, rounded pointed tip, to score grooves axially along the along this taper that will hold the lap. I probably don't have to do that, but it figured I'd put a few little pockets in there to hold it, to keep it rubbing a little longer, I would think. And I'm turning at my slowest speed. I mean, this isn't, I don't have the back gear engaged, and I've got the variable speed all the way up. So, I mean, we're turning at the slowest speed that this lathe would have turned at on a 1725 RPM motor without back gears engaged. Alright, more, and you can see a little wobble in that. Put a little bit of pressure on it if that's necessary. The metal expands as it gets hot. It doesn't even feel warm yet, but it expands out and starts pushing against the spindle bearings, against the thrust, the spindle thrust, and will jam the spindle. If you're not careful and the work starts heating up, you've got to adjust your tailstock unless you've got roller bearings in here. I mean, this is an older lathe with plain bearings and a plain thrust bearing. If you've got to pay attention to heat. There's got to be a certain amount of clearance in there for the oil to provide a film. I mean, you can crush it. I'm going to upgrade the thrust bearing to a ball bearing here shortly. McMaster-Carr has a kit for, or it's not a kit, they have the bearing and the hardened washers for it for, it's only like $30, so that's a worthwhile upgrade. I will pay for that. I'm not going to pay for Morris Taper 3 reamers. Those things are 80 bucks a piece, and I'd have to buy two of them, a finishing and a roughing reamer, and I'm not spending $160 in tooling when I have a tool that makes tooling. So I'll make the tooling to fix it. We'll start from the ground up. And that looks like we're pretty, and we're clear. And actually looks like I've got plenty of room for engagement and a decent surface finish. Yeah, I'm down to 860, 862 on the minor diameter here. That means I can take this out, and I can take the chuck out, and I can check the fit to see if this taper is matching. I'll blue it, check it, and see where I'm hitting. If I'm hitting on the top, then I have too much taper. If I'm hitting on the bottom, I have too little taper. I should be hitting squarely across here. There are a few raised bumps in there that I'll have to dig out, but this can get me close. Alright, I've taken it out. I've put bluing on, and I've skimmed it off so it's just a very light coating. It'll be easy to read. Alright, sorry for kicking you. I'll place it into the headstock. I've cleaned this. I wiped it out with my fingers to make sure it was no contaminants. Well, how about that? I'm dead striking it right in the middle. Now it's not, that's a bit of a high spot. There's a high spot there. It's definitely something grabbing a burr, but here we are right in the middle. My taper is from here to here, and my contact's right in the middle. So the math was perfect. The math was perfect with the part that was perfect. Or at least according to the numbers. So this taper is correct. I won't change any setup on the machine. I'm going to go ahead and cut the rest of it so that I can get the minor diameter here smaller than the minor diameter inside the taper, so I have a little bit of room to work back and forth. And I'll probably put a T-handle in the end of it. So I'll put a bar, I'll drill a hole across here so I can put a bar in so I can hold this. And like I said, I'll put some grooves axially, probably 4 or 5 of them, just to hold the lapping compound while I'm turning it. Alright, I'll get you set back up. We'll cut the rest of the taper, and then when I get some lapping compound, I'll show you the lapping process. Okay, so we're at 760. Take another 10/20. We're down to 740. We should be with this cut. That takes us to 740. We have another 15 to go. That would leave us 7. I'm going to do 5 and 2. Alright. Step my increments down. I'll do 5, and I'll do those on the higher speed, because the taper's getting a little long in the tooth now. It's getting taking a while to cross this length. I'm sure I'm going to speed this camera up, so that's it. That's it. I believe we nailed it here. Alright, so before I take that out, I'm going to swap around this bit, flip it over, and get it aligned to where it's on center, and I'm going to scrape some grooves into this. thousandths. And another 5. Did it turn it? I believe it did. So I said it wasn't going to do that, and it did. I think I need to lock the back gears in place if that's the case. Alright, back gears are locked. We're not going to turn this time now. Whoa, what? Oh. Now see, how am I thinking this? That it's not going to turn. The dog isn't even locked in.